Alright, so in this video we're going to talk about solving rational equations. Notice that keyword rational again when we talked about rational numbers earlier on. So what does rational mean? Well, rational means that we're going to be dealing with a quotient. Specifically when we're talking about a rational equation or a rational function, it means that the denominator is going to have a variable in it. Now, in this video we're not going to do any examples of solving just linear equations, but that is also part of this unit. However, if you can solve a rational equation, you should be able to solve a linear equation, because part of the process of solving the rational equation is converting it to a linear equation. Okay. So, first thing we want to understand is a little bit of vocabulary. Again, this is on your Unit 1 packet, but first, least common denominator. So what is the least common denominator? It's the simplest expression that every denominator is a factor of. What does that mean exactly? Well, let's look at a few examples. So we have these three examples here. These are all expressions because there is no equal sign. So we have 1/3 plus 1/6 plus 7/4. Now I don't want you to actually simplify any of these. I just want you to find the least common denominator. So for example, if I look at 1/3, 1/6, and 7/4, well, I can ignore the numerators and I'm just looking at the denominators. So 3, 6, and 4. And so if you look back up at that definition, what is the simplest expression that every denominator is a factor of here? So I can think of that as, well, okay, I'm looking for an expression, and in this case, since each denominator is already just a number, I know that that expression is also just going to be a number. Whereas if I look at the other two examples here, there's going to be variables involved. That's okay. So now I want to think about the smallest number that every one of these values is a factor of, or every one of these denominators is a factor of. So what is the smallest number that 3, 6, and 4 are all factors of? That's going to be 12. 6 is a factor of 12, 3 is a factor of 12, and 4 is a factor of 12. Now notice that had it just been 1/3 and 1/6, the least common denominator would be 6. So then let's look at 1 over x squared minus 9 plus 5 over x plus 3. Well, first you want to think about what are the factors of x squared minus 9, because this might simplify, and in this case does. So x squared minus 9 is actually x minus 3 times x plus 3. And this denominator here has x plus 3 in it. So therefore the least common denominator is x minus 3 times x plus 3. Or you could write it as x squared minus 9. So either this form or this form are correct because they are both the same thing. But that is the least common denominator because it is the simplest expression that every denominator is a factor of. So x squared minus 9 is a factor of x squared minus 9. X plus 3 is also a factor of x squared minus 9. Alright, so I want you to look at the last example here and find the least common denominator. Pause the video. Unpause when you're ready to check your answer. Alright, so again, here there's two ways in which you could write the least common denominator. It's either x minus 6 times x plus 2, or if you multiply that out, you get x squared minus 4x minus 12. And again, here we're looking at, well, what is the simplest expression that has both of these denominators as a factor? Well, since these denominators are independent of each other, we have to just write the product of those two denominators. Alright, so why do we care so much about finding the least common denominator? Well, because it's our first step in solving rational equations. Now, these 4 steps that we're going to go through here, this is not the only way to solve a rational equation, but all of the other methods that you might come up with are actually going to be very similar to this or relate to this probably in some way. So you don't have to solve a rational equation in this process. This is just the process that we are going to go through on the video. So first thing, find the least common denominator. So take a second and think about what is the least common denominator here. Write it down. So in this case, hopefully you wrote down that the least common denominator is going to be 4x. The denominator here is 4, the denominator here is x, the denominator here is 1, so the smallest thing that contains all of those as factors is 4x. Now next step, this is key. Multiply each term, so that's a term, that's a term, and that's a term. We're going to multiply every single term by the least common denominator. The reason why we're going to do this is this will actually eliminate the denominator. So if we have and we multiply each one of these by 4x over 1, now when I multiply 4x over 1 times 1 over 4, the 4's cancel and we're left with x. When I multiply 4x over 1 times 14 over x, the x cancels and I'm left with minus 4 times 14, which is going to be 56. And when I multiply 17 times 4x over 1, I just get 17 times 4x, which is going to be 68x. Now what we have left is a linear equation. So here we hopefully know how to solve linear equations. That's why we're not going to focus on that. But we will go through this process. So what do? Well, we get all the x's on one side, so I'm going to subtract x from each side. So we're going to get negative 56 equals 68x minus 1x is going to be 67x. And then we can divide both sides by 67. Those cancel. And we're left with x equals negative 56 over 67. Now, the last step we have when we're solving a rational equation, and this is only with rational equations, or, well, it'll come up in other situations as well, but specifically it is not with linear equations. So if the initial problem is a rational equation, which again remember means we have fractions, specifically variables in the denominator, then we have to check for extraneous solutions. Well, what are we checking for with extraneous solutions? What we're checking for is if I take that value, negative 56/67, and I plug it into the original equation, so it has to go into the original, does it make the denominator 0 anywhere? And so in this case I can see that if I plug in negative 56/67 right here, the denominator is negative 56/67. That is not 0. Therefore, it is not going to be extraneous. So we checked. What does extraneous mean? Well, again, that's in your note packet. But extraneous solutions are basically solutions that you found by doing all of your algebra correctly. However, when you plug them back into the original equation, and again, it has to be the original, they don't actually work. Okay, so now, before we go on to the next example, I want you to think about, is there a different way in which you would have approached solving this equation? And again, there are different ways in which you can solve this. So I want you to write down or think of a couple of different ways in which you maybe would have solved this equation. They might be very similar to what we did here, but just a different way to start the problem. So go ahead, pause the video, think about that, write them down, unpause when you're ready to discuss. Okay, so two different techniques. Again, the first one especially is very similar to what we did anyway. One would be to find a common denominator. So this is very similar to multiplying by the least common denominator, because you are actually finding the least common denominator, you just aren't multiplying by it first. So I could multiply the top and the bottom of the first term by x, and the top and the bottom of the second term by 4, and then this would become x minus 56 all over 4x equals 17, and then I could solve from here. Another method would be to graph both sides of the equation. So in my calculator I could put y1 is 1/4 minus 14 over x, y2 is 17, and then find the intersection of those two. So again, these are just two different methods. The first one is very similar to what we did. Either of them work. It's really up to you. Okay, so now on your own, I want you to solve this rational equation. Pause the video, go ahead and solve it any way you want, unpause when you're ready to check your work. Okay, so you should end up with x equals 7/4, and I checked to make sure that was not extraneous because it did not make the denominator 0 anymore. How did I get that? I found out that this x squared plus x minus 6 factors into x minus 2 times x plus 3. Since this is a denominator of x minus 2 and this is a denominator of x plus 3, the least common denominator is x minus 2 times x plus 3. So I multiplied the entire thing by that. When I multiplied by the first term, the x minus 2's cancel, and I'm left with 1 times x plus 3. So I have 1 times x plus 3. When I multiply the least common denominator by the second term, the x plus 3's reduce, and so I'm left with 3 times x minus 2. And when I multiply by the other side of the equation, the interior denominator cancels with the least common denominator, so I'm left with just 4. Now I solve that linear equation, distribute the 1, distribute the 3, combine like terms, divide by 4, and I get x equals 7/4. Again, what I'm looking for as far as extraneous solutions is if I plug in 7/4 here, is 7/4 minus 2 equal to 0? Is 7/4 plus 3 equal to 0? Or if I plug it into this expression, do I get 0? And the answer is no. Therefore, it is not an extraneous solution. It is a good solution. Next one. Solve again, however you want. Pause the video, unpause when you're ready to check your work. Okay, so with solving this, we should end up with x equals -4 and x equals +3. However, +3 is extraneous, so our only solution is x equals -4. Now, how did I get that, if you were confused? Well, first I factored x squared minus 9 into x plus 3 times x minus 3. So I saw that the least common denominator is x plus 3 times x minus 3, or x squared minus 9. Those are the same thing. So I chose to multiply the entire equation by x plus 3 times x minus 3. When I multiply by the first term, the entire denominator cancels, so I'm left with just a 6. When I multiply by the second term, the x minus 3 reduces with the x minus 3, so I'm just left with -1 times the quantity x plus 3. It's really important that I recognize that minus sign is on the -1, and that's going to get multiplied by this quantity x plus 3. If I don't recognize that, things are going to go wrong. And then when I multiply the least common denominator by 1, I end up with just x squared minus 9, or x plus 3 times x minus 3. Now this becomes a quadratic equation. So I distribute the -1, bring everything over to one side, combine like terms. This is a very nice equation. It factors into x plus 4 times x minus 3. Since this equals 0, I can set each factor equal to 0, and that is how I get my solutions of x equals -4 and x equals +3. I go back up to the original equation, and I notice that if I plugged in a +3 here or here, I get 0 in the denominator. As long as it gives you 0 in the denominator in one spot, it fails, or it's extraneous. Again, just to re-emphasize, this process is not the only way to solve rational equations. It's just, I think, kind of the simplest method, or the most structured method. So if you go through this process, you're going to get the right answer.